Good afternoon, students.
Good afternoon.
So we have, is the screen visible to you?
Yes.
We have completed till permutation and combination. So today we are going to start with mathematical logic.
Mathematical logic.
You are having your exams from 12th Feb, right?
14th.
It's from 14. When is the maths paper then?
14th, 15th, 17th, I think, or 18th.
Okay. Okay. So here we are. Now mathematical logic. You must have heard this term in your 12th standard maths, correct? That was, we had it statements over there. True statements, correct? The truth value statement, where we define whether the statement is true or not. The other one are compound statements, conditional statements, converse, inverse. All of these terms are known to you in your 11th and 12th maths. So when we start, first we define a statement. A statement is defined as a declarative statement which is either true or false, but not both at a time. Obviously, now let's see the examples. The earth rotates around the sun. Now here you can either define whether it is true or false, but we know does earth rotate around the sun or sun rotates around the sun, earth? What is the answer? This
Earth
sentence
rotates
is
around the sun. True.
so it is a true statement. It is not raining today. Now here, do we have some specific? First of all, ing is there, so it means it is a continuous
Continuous
sentence.
tense.
So it is not giving me a perfect statement that whether the given information is true or it is false. Therefore, here it is also a statement. Give me that book. Now this is just, what should I say, a action given to a person. So it is not a statement because we don't know. I can't define whether it is true or whether it is false. Now again, a question mark statement. Are you interested in cricket? This is also not a statement. Now let's check this. The positive divisors of 10 are 1, 2, 5 and 10 only. So this is a true statement. All of these are what? Divisors of 10, which we know. So it is a true statement. And so on. So now we are going to discuss truth value of a statement. So let's take the above example. The earth rotates around the sun. We know this statement is true. Therefore, it is a logical statement and it will have a truth value of T. That is the capital T. Now let's see. 4 plus 15 is 19. Is 19 greater than 20? Obviously not. See. 4 plus 15 is 19. Is 19 greater than 20? It's not possible, na? So the
False.
truth value is F.
False. Yes. F.
18 is the prime number. Now, what is the definition of prime number? It should either multiply itself, correct? Do we get 18 only once? That is 18 ones are 18 is there. After this, 9 twos are 18 is also there. So obviously it is having multiples of 18. So it will have truth value of F. Now this is for your homework. Now logical connectives. Now in that types of logical statement. The first one is simple statement. Simple statement means what? Just a normal, where it is just defined. There is no connectivity in between. Means we don't use and, we don't use or, nothing like that. Now see here, London is in England. That is a simple statement. Same way round 21 is a multiple of 9. Now compound statement, what happens in compound statement? You will have and in between. See, if a statement is formed by joining two or more simple statements using logical connectivities, then it is called as compound statement. So for example, Mumbai is in England and it is raining. So here they have formed two simple statements are there. The first one is Mumbai is in England and the second one is and it is raining. And we have combined these two simple statements by a compound statement, that is and. Now in compound statements, we have to define the types of compound statements. Now see, when you're forming truth table, na, so if you're having two of them, at that time, you will have how many rows? There will be two, means total you have to have four values. See here, when you're having PQ, let's go by your textbook only. The first thing over here, it is negation. Now negation means what? The opposite of it. If P is T, the negation of P will be F. If P is F, the negation of P will be T. See, the example is given. In P, if it is logic is easy, in negation P it will be logic is not easy. Now see, here they are having not now. So you must be thinking already it is in negation. But we need to find negation of P. Here, even if there was not, in negation P, the not will be gone. Because we are taking negation of negation. And there's one more thing. When you find negation of negation P, it is always P. Conjunction. Now, what are the conjunction type? There will be and. Now, here the symbol is something different. For and symbol, we use this. Is it there? Yes, it is over here. Now see, if you are having two elements, now that is P and Q, means two sentences are there. At that time, your values will be of how many forms? Four forms. Keep in this mind. So if you are having two sentences, that is P and Q, then total how many values you are going to have? Four values. And how do we get this number? It is by 2 raised to n formula. If you are having n sentences, then how many values you are going to have? 2 raised to n values. So if you are having two sentences, you will have 2 raised to 2, that is 4 values. Understood this? Now see, we are talking about and. Now what happens in and? If P is T, see, here is your example. Now how do you define? Now see, if P, we have the values. Sunday is a holiday. Q is what? Every day I study for at least 4 hours. So you need to find P and Q. So conjunction of P and Q will be Sunday is a holiday and every day I study for at least 4 hours. Now, in case of conjunction, the statement P, now see over here. If the values both are true, the statements of this both are true, then the value is true. Otherwise, if one side of the sentence is false, it will be always false. See See, if P is T, Q is F, the whole statement becomes a false value. And also for false false, it will always have F value. Now disjunction means what? Or. See, conjunction means and, disjunction means or. Now what happens in or is, the only difference over here is, you are going to get F when only both the statements are what? False. Only at that time your disjunction statement will be false. Otherwise it will be always true. Keep this in mind. After that, conditional statement or implication. Now here, how do we read this statement? P implies Q. Now in this statement, there's one more thing. Now these statements, how they start is, if P, then Q. See, if P, then Q. Or else there are many ways. P only if Q. Now see, sometimes what people do is, they don't write in this form. They keep Q over here and P over here. So your P should be over here. P only if Q. Q provided that P. Q if P. P implies Q. P is sufficient condition for Q. Now see, in this mostly this phrase is used. That is, if P, then Q. And after that, rarely this one is used. Keep this in mind. Now let's take the example for this. See, in this condition, you're going to get F when, if your Q statement means the last statement, if your starting is true and your ending is F, only at that moment you're going to get F. Otherwise, it is always T. And the symbol for that is P implies Q.
Which symbol is that?
Okay, wait, let me draw properly. P implies Q. This is the
No,
symbol.
in the box they are representing P implies
This
QA.
one. This,
Yeah, this is the upper.
no, don't think about that. I'm drawing over here. See, this is the symbol
Oh,
over
okay,
there.
okay, okay.
See, here they have taken it correctly, but don't know about the box. See, over here they have the symbol correctly. The box symbols are
The
different. Don't
box.
go on side.
Yeah, yes. Okay.
Now, after that, biconditional statement. Now, we can also call this as double implication. So here your statement will be P if and only if Q. Now here you are going to have two false values. When are those false value? T double implies F, or else F double implies T. Because you're not having a specific value, na? It's going one on the round. If you start from T, double implication will be there. F, you're not, means you're not on the stable table. It can be T, it can be F, it can be T, it can be F. So we have to take the value as F. Same way round, if we started with from F, it is also the same thing. So therefore F value. So you need to just remind, means keep revising this chapter. It is so easier to understand. Now see, here their symbols are not proper. You can study from here. That what all they have asked to find: PQ, negation Q, P and negation Q. Now this symbol is what? And. Keep this in mind. So how will you find? Now negation Q is there, means opposite of all of this. T is replaced by F, F is replaced by T, T is replaced by F, F is replaced by T. Now here what is the symbol? P and negation Q. P and negation Q. In and, all the values are true only when both statements should be true. Otherwise everything is false. So TF is there, so F. TT is there to true. FF is there to F. and ft is also there to f. So this way you can solve the sum. If you see now here, if you are having three simple variables p, q, and r, at that time you can see the combinations 2 raised to 3 because I am having three variables. So you need to find how many rows? 8 rows. So there's a trick over here. What you can do is first write the p. How you are going to write the p is the first four are T, the last four are T. After that, Q and R are taken as TT, TF, FT, FF. And again, TT, TF, FT, and FF. This is the simplest way you can understand. It will be easier, Nana, to keep in mind. Now, logical equivalence. Now, when do I say P and Q are logically equivalent? Both of these terms. When C, P implies Q, can also be written in which form? That means both of the values of P implies Q and negation P or Q. Both the rows or the values should be same. Let's take this example. We need to prove it. Huh? So we have taken P implies Q here and negation P or Q taken over here. So negation, now you know P implies Q. When do I get false value over there? Only if the Q statement is false. You can see over here, TT, TF is taken as F, otherwise it is T. Now we need to find negation of P, that is opposite of all of this. So we have taken over here, negation P or negation Q. Or symbol is there means even if only when do I get false value over there? If P and Q both the statements are having false values. So negation P or Q. Negation P is over here or Q. FT is there so T, FF is there so F, TT is there so T, and FT is there so T. Now look at the column 3 and 5. You understand? All the values, truth values are same. Therefore, we can say they are logically equivalent. Understood? Now, there are few logical identities. See, earlier I told you, negation of negation P will be P only, na? See, here it was T. I took negation of the C of this. Q is there. So negation of Q is F. If I am taking again negation of Q, so F will be converted to T. Understood? Now this one is the De Morgan's law. Negation, the whole negation will be there. P and Q. It will be represented in which form? Negation P or negation Q. See, this De Morgan's law is on a set theory also. There we use complement. Means A union B, the whole complement will give me A complement intersection B complement. In that form. Commutative law, P and Q, logically equivalent, Q and P. Associative means if you are multiplying this both together and the other cases, if you are if you are using this operation together first and after this, they will be same. Now distributive means if see P and Q or R, it can be represented in this form. P and Q we have taken first or P and R. Now P implies Q. It will be similar to what? Negation P implies negation P. And double implication will be there then. P implies Q and Q implies P. See, all of these terms are, you have to learn it properly. Revise it. Now see, we have two conditions. That is tautology, contradiction. Now tautology means what? All the last value of a column will have T in it. See, all values in the last column are t, then it is called as tautology. And contradiction means all the truth values in the last column will have f values, then it will be contradiction. Now I don't know whether you're having or not in your exam. There's one more thing. If there are random means t f f t something like this is there in the column, then it is called as contingency. It's not there over here, but still for your knowledge, it is called as contingency. Means it is neither true values nor false values. It can be TF, FT, whatever in the last column. Now after that, converse, inverse, contrapositive. Converse of a conditional statement. See, originally our statement is in which form? P implies Q. Now converse means Q implies P. Means Q implies P. Converse, opposite, inverse. Inverse means negation comes in it. After that, contrapositive means opposite of it. See, con is there. So con will be Q implies P. Now contrapositive is used, therefore negation Q implies negation P. Converse was there, so Q implies P. Now let's take an example. If two triangles, see, if two triangles are congruent, then their sides are equal. So your first P value is what? Two triangles are congruent. Then after that statement, their sides are equal. So it becomes your Q. So it is in the form P implies Q. Converse means Q implies P. So Q implies P is if their sides are equal, then two triangles are congruent. Inverse means negation P implies negation Q. So if no two triangles or if two triangles are not congruent and their sides are not equal, contrapositive. If their sides are not equal, then two triangles are not congruent. This is in this form. Understood this chapter? Sorry, this unit, that is
Yes.
mathematical logic. Just revise what all is was said. Try to solve these sums. If you have doubts regarding it, you can ask me. Now we will move further. See, all of these are not so lengthy chapters, lengthy units. You can complete in one day. Now relations. Now we studied this chapter in which term? See, we have completed set part, understood that. Now here we are going to discuss the Cartesian product. You remember, Abhilasha, you had asked me the R cross R
Yes, ma'am.
Cartesian product. So we are
Yes.
going to study it over here.
Hmm.
Now relations are what? We know in normal life the relations are what? Father, mother, brother, husband. Family relations are there, right? So here, let's see this example. A is taken as eggs, milk, rice, bread. B is taken as cow, goats, and hen. If I am saying if an element X of set is produced by an element Y of set, this is what your relation. Then X is related to Y, otherwise X is not related to Y. Now let's take eggs. Okay, eggs are what? Product of cow. So X is related to Y. You can say that. Let's see milk. Milk is also of, all of this should be related to this. Eggs, this, and also this. Milk goes to cow, goat. But it is not related to hen, na? There are some conditions over here. Correct? So for that we need first thing for relation is Cartesian product. Okay. So let me just show how do you represent. There are two types of Cartesian product. The first one is with AB and the other one is with A cross A. Now A cross B, it will be all the elements of A, comma B, where A belongs to the capital A and B belongs to the capital B. For example, now see, you need to find product of this. So your first will be C Windows, C Unix, C DOS. C is completed because we are having L cross S. If it was S cross L, it will be Windows C, Windows Pascal, and Windows COBOL. So here we need to find L cross S. So all the terms of L will be at the first component. See, this is called as first component, and this is called as the second component. And this, the A comma B bracket is called as order pair. See, set of all order pairs. So C is done. After that, Pascal. Pascal Windows, Pascal Unix, and Pascal DOS. COBOL Windows, COBOL Unit, and COBOL DOS. All of this are done. So this will be a Cartesian product. Now after that, again, the same way A cross B and B cross A. But you will understand, even if we take A cross B and B cross A, they both won't be same because your first component is different. See, in this case, you are not having AC, na? AC is there in BA, but it is not in, sorry, AC is in AB, but it is not in BA. So they both are not same. Means they are not commutative. After that, we define relation. Relation can be said subset of Cartesian product. Subset of Cartesian product. Why? Let's see. The earlier example. Milk, cows, eggs and hen. Means A, B and C, D is taken. And it is the set P. Now here we are defining a relation. What is that? P is a relation as it is as sets of order pair. Now we can say that A is related to B if and only if A is produced by B. Now I can say now milk is produced by the earlier example. Only this is there na possibility. Yes or no? Milk is produced by cow. Eggs are produced by hen. Only this
Hence.
relation will be there. Earlier A and B were this part. You can see cows, hens. And there was one more thing in this example. Where is it? Goat was also there, na? Goat. Here. Goat were also there. So if I have to define relation, it should be a production. So eggs and cow will be there, correct? Eggs and goats will be there. Okay. After that, milk and cows will be there. Milk and goats will be there. Rice and bread doesn't matter because both of them don't give us. Done. So it will be your relation. So you can say relation is what? A relation R from set A to set B is a subset R of the product set A cross B, which is nothing but your Cartesian product. Understood? So in our example, you needed to find R cross R, na? So over there, your R values were A, B belonging. Means here it was, let's say, here your R was starting from 1, 2, 3 up to infinity. And this R was also from 1 to 10. So originally it was nothing but R square. So your representation will be A comma B, where A belongs to R and B belongs to R. This will be your set. Now after that, if it is not related now, see, here you can see. How do we read it? If it is related, we say A is related to B without this symbol. And if it is not related, see here it is A related to B. If it is not related, A is not related to B. Now here, domain means what? If A, all the elements from the first component. See, this is called as first component, that is A, and B is called as the second component. All the elements from first components are called as the domain of the relation R. And all the elements from B, that is all the elements from second component, are called as range of the relation. If A is equals to B, then R is called a relation. See, binary relation. I told you, A cross A. So R cross R. Now all of these sums are there, A cross B. You can do it now. Just you need to add. Here they have just asked the Cartesian product. Now here we are going to discuss types of relations. There are 4 types. But here how many they are having? Let's see. The first one is 1-to-1. Now what do you understand 1-to-1? That A should be uniquely defined, not defined. A should be uniquely related to only one element. See, unique element of set B. If every element of A is related to a unique element of set B. You can see A is related to 2, B is related to 1, and C is related to 3. So they are uniquely related. Therefore, this becomes a 1-to-1 relation. After that, one to many. See, one to many. B is related to 1. B is related to 3 also. So it becomes a 1 to many. You can see the example. A 1, 3, 7, 9. B is taken as 1, 5, 15, 20. So now define a relation R from set A to B as A comma B belongs to R if and only if A is what? Less than B. Less than B. 1, 1 will come. Will it be 1, 1? No, because they are saying A should be what? Less than B. So 1, 5 will come. 1, 15 will come. And 120 will come. Obviously, you can see how will be the graph over here? Means the Venn diagram. Drawing too small. I'm just talking about 1 right now. So your values are 1, 5, 15 and 20. So relation of 1 is with whom? It's related to 5, it is related to 15, and it is also related to 20. You can understand it is 1 to many. After that, many to 1. See, 2 is related to A, it is also related to C. So here, if and only if A square is equals to B, so minus 2 in this format. And after that, many to many. Means anything is happening. A is related to 1, A is related to 2, 1 is again related to B. Understood all of this relations? Now, when do we define equivalence relation and equivalence classes? There are 3 relations, reflexive relation, symmetric relation, and the last one is transitive relation. Now, reflective relation means what? If you are having a reflection relation, if A comma A belongs to R for every A belonging to R. So A should means A comma A should be there. For example, let's take this one. A value is there. Your relations are 1, 1, 2, 1, 3, 1, and so on. Then R is not a reflexive relation. Why is it not a reflexive relation? Can you say? See, 1, 1 belongs to R, so A belongs to R. 3, 3 is there, so 3, 3 belongs to R. But 2, 2 is not there, na? You can understand. 2, 2 is not there, therefore it is not a reflexive because we need A. Now in symmetric, if AB belongs to R, then BA belongs to R. Means if you are having AB, it should also have BA. For example, if this is your ABC and relation is AA, BB, BC, CC and CB. You can see BC is also there, CB is also there, and AA and BB and CC are there. So you can say all of this are what? Symmetric relation. Now transitive means one more element is required. That is, if AB belongs to R, BC belongs to C, then AC should also belong to R. Means the middle point, AB, BC. So they are saying the whole AC will also belong to R. For example, there another one, this one, ABC are there, AA, BB, BC is there, CC is there, CB is there. For transitive, what I need is AC I need, right? Yes or no?
Yes, yes, ma'am.
But it is missing over there. Yes or no?
Yes. So this is not transitive.
No, it will be transitive. Why it will be
Oh,
transitive?
yeah,
For
yeah, yeah.
that I will see. A is there. After that they are saying, here we observe the R satisfied as xz belongs to for all xy belonging to this form. So here you can see A is there, it should belong to, if I'm saying x value is A, y value is A, so obviously z value is what? A in this condition. Same way BB is there, so z value will be B. Now I'm talking about what? CC also it will be the same. And we know BC is there, so CB is also there. So obviously it is a transitive relation. And equivalence relation means all these three relations should be there. That is reflexive relation, symmetric relation, and transitive relation. All of these three are there. See, a relation R on a set A is an equivalence relation if it is reflexive, symmetric, and transitive relation. Okay. Now equivalence class. If R is an equivalence relation defined on a set A, and if A belonging to capital A is any element of A, then the equivalence of class A is defined as the set of all elements of A which are related to A. Means we have to just take all the elements belonging to the A part. Let's see this example. A equals to 1, 2, 3, 4, and I am taking this as my relation. R is an equivalence relation. They have said it. Now you need to find equivalence class of 1, equivalence class of 2, equivalence class of 3 and 4. So let's talk about equivalence class of 1. Now what all elements of 1 are there? You can see 1 is taken when only 1 3 na, because these both are same, so only 1 3 is there, so one element is there. After that 2, how do I get 2? Only one, that is 2 2. After that 1 3. See the elements you have to take. You can see first elements are 1, in 2 only 2, and in 3 how do you get 3? By 1 3, means here 3 value is 1, and here the 3 having is 3, and 4 4 has only 4. See, we have to not take, you're not understanding what I'm saying. Let's check over here. A bar is there, okay? After that, x belonging to A, if here they have taken A comma x, means your A is on the first component and you have to pick up the x part, that is this part, the second part. So for one equivalence class, you can see, where do I find 1? Here now, the x value is 1. Understood? For equivalence class of 1, you can see here the value is 1. Okay. And ithe one, that is 3. You can see 1 is also there. This 1 from the second component and 3 from the second component. Again for 2, 2, where do I see 2? Here. So this is my A, and x is what? 2. 3. Where do I see 3? Here I am having 3. So x value is 1. Again, here is 3. So my x value is 3. For 4, again my x value is 4. In this way, you are going to find the equivalence class. Now, after that, you're having matrix of relation. What is there in this? Will it be lengthy to us? Let's see. When the number of elements in a set is more, the listing of relation on it in the form of order pair is not easy. Obviously, if you're having many multiples, then it will be not possible for us. So at that time, we are going to use matrix. If A and B are two finite sets containing M and N elements respectively, and R is a relation from set A to set B, the matrix will be in which form? R is there, A and B. So M cross N will be the form where M is from A set and N is from B set. So it will have containing entries of zeros and ones. It is a matrix in which rows correspond to the elements of set A. So rows M cross will be from A and columns will be of B. Don't forget about it. And it will be 1 or 0. Now see, then the entry in the row corresponding to element A and column corresponding to B is equals to 1 and it is equals to 0 otherwise. For example, let's take this example, then you will understand. A is taken as 3, 5, 8, 15. B is 5, 10, 15. And they have defined a relation. That is 5, 5 and 15. Now matrix of set of relation of matrix of order 4 cross 3. Why I have taken 4 cross 3? 1, 2, 3, 4 elements are there in A. So n value is 4. 1, 2, 3. So n value is 3. It is a matrix in which rows correspond to the elements. So rows are what? 3, 5, 8, 15 in that form. And the columns corresponding will be 5, 10, 15. Now this is the only relation. Now you will understand how it's going to work. Now you can see. In the matrix of relation S, the entries in the row corresponding to the element 5. First one is the 5. Let me show you. Here is what? 5. Here is 10. And here is 50. And the 4 are 3, 5, 8 and 15. 3, 5, 8 and 15. In our relation, you can see how many are there? 2. That is if 5 is related to 5. At that time, the value will be 1. And for how many value? 15 and 15 will give me value 1. Here is your... Okay. Why is it gone in this form? Sorry for that. Still you can understand, right? What I'm trying to say.
Yes,
Here
ma'am.
will be a 5, 10, 15. Here 3, 5, 18 and 15. So you can see 5 related to 5 is giving me 1 and 15 related to 15 is giving me 1. Otherwise, I'm not having any relation. So on that part, all of them are in the 0 format. Understood? Only the relation giving to us is taken as 1. If the relation is not included in this sentence, then you have to use 0. Now let's see of this. First one is 3, 5. 3 is over here. 3, 5, 8 and 15. 5, 10 and 15. So you can see 3, 5 taken as 1, 3, 10. 3, 10 is also taken as 1. 3, 15 is there. 3, 15 is taken as 1. 5, 10. 5, 10 is taken as 1. 5, 15. 5, 15 is taken as 1. 8, 15. Where is my 8? 8 is over here. 15 is over here. So 1. Understood? Yes or
Yes,
no?
ma'am. Yes, ma'am.
So you know now how to define a matrix also.
Matrix.
How much part is there now? Only this one is there. We will complete it. Closure of relation. Closure of relation. Let R be a relation on set. The smallest relation R star on the set R that contains R as a subset means the smallest relation of R. For example, let's see over here. There are how many closures? Same way, how many relations we had? Reflexive, symmetric, and transitive. The same way round, closures will be reflexive, symmetric, and transitive. So reflexive was what? Let R be a relation on a set A. The reflexive closure of R is the smallest reflexive relation. Nothing, you have to change nothing, only T. Reflexive closure means what? Smallest reflexive relation on A that contains R as a subset. Same way, symmetric is what? Symmetric, smallest symmetric relation. Transitive is smallest transitive relation. Now let's take the example. A is taken as 1, 2, 3, 4. R is defined 1, 1, 2, 2, and 3, 3. Now reflexive closures will be what all? 1, 1, 2, 2, 3, 3, 4, 4. Now symmetric closures. What for what? A, B belongs to R. B, A should also belong to R. Let's see over here. 1, 2, 3, 4 I is a set. R is defined 1, 1, 2, 2, 3, 3. So your symmetric closures will be A, B, B, A. So again, A values will be 1, 1, 2, 2, and 3, 3. Transitive means AB belonging to R, BC belonging to R. So AC should belongs to R. See. AB belonging to R. If I am saying AB belongs to R, so I can also say it is BC belonging to R. So 1, 1, 2, 2, and 3, 3. So understood till here? It is nothing but smallest means each relation should be a smallest relation. Then it is what? A relation closure. So today we have completed 2 units. The first unit was of what? Mathematical logic
Mathematical logic.
and then relation. Do you have any doubts?
No, ma'am.
So we will stop over here.
Thank you.